All right, you guys going to sit back and relax and get to know some common acid and bases. Okay, so this is where you can find an acid. If you see group 7, proton of group 7. So we got all these acids, right? The strong acid are hydrochloric acid, bromic acid, and iodic acid. So down here, hydrofluoric acid is a weak acid. Okay, hydrogen that bond to electronegative atoms, so like oxygen, nitrogen, sulfur, these are also an acid as well. So for chlorine, so we have chlorine of acid, we have chloric acid, perchloric acid, those are strong acids. These two, right? We have sulfuric acid, nitric acid, and then hydronium ion. All right. What we get a base, so group 1, remember that hydroxide of group 1, those are strong bases: lithium hydroxide, sodium hydroxide, and potassium hydroxide. Group 2 as well, but not all group 2 though, because some of them, so only calcium, strontium, barium hydroxide are strong acid. Beryllium and magnesium hydroxide could be a strong basis, but we don't really call them a strong basis because they are not soluble in water. But if you pour an acid into it, they actually react. Okay, and we also have acetic acid, ammonium ion, those are strong acid. Weak acid, and hydrocyanic acid or hydrogen cyanide, also a weak acid. The base, so we have one weak base, so ammonia. Okay. All right. When I say strong acid, what do you mean by strong acid? Strong acid dissociate 100% in water. Right, so hydrochloric acid dissociate 100%. If you add 100 molecules, all of them dissociate. Nitric acid in water, if you have 1,000 molecules of nitric acid, all of them dissociate. Okay, let's take a look here. Let's take a look in action. Drop hydrochloric acid in water. So those are hydrochloric acid molecule. Most of them dissociate. Maybe some of them not dissociate, but really, really, really small. Most of them dissociate. That's the reason why most of hydrochloric acid can go to work, can do reaction, because they dissociate proton. Right? The one that stay in the molecule just stay because it's stable right there. Doesn't do much of reaction. Now, weak acids, on the other hand, partially dissociate. Not all of them dissociate. Okay, only small amount. Hydrofluoric acid, not all of them dissociate to fluoride. Right? Acetic acid, which is a weak acid, not all of them dissociate. That's the reason why we can use acetic acid for eating, put in salad or something. Right? Not all of them can do reaction. So if you have a weak, let's say this amount of molecules of weak acid, only some of them dissociate, maybe 1, 2, 3, that's not a lot. And they are in equilibrium. So some of them dissociate, some of them stay, go back and forth, right? Can go back and forth like that, right? And strong or weak acid, we use the dissociation constant. If you still remember Kc, right? In this chapter, we use Ka, which is a dissociation constant of an acid. Okay. Let's check on the next.